In this video, we'll be talking about a couple of special factorising rules. Normally, it's not really that helpful to remember these kinds of things, but these come up so often that it's worth knowing them. So you might have already heard of the difference of two squares factorisation. That's this one right here. X squared minus y squared, the difference of two squares, is always equal to x plus y times x minus y. Now, there's a couple of other things like this as well that are quite common, and two of them are the sum and the difference of two cubes, x cubed plus y cubed and x cubed minus y cubed. So we're going to look at how these rules come about, one of them anyway, and also look at how we go about using them. First of all, let's look at the difference of two squares. The difference between two squared quantities, x squared and y squared, x squared minus y squared, can be factored, as we said a moment ago, as x minus y, x plus y. Now we can show that that works by expanding out that factorized form. So if we start with x minus y, x plus y, and expand using the distributive law, we're going to get x times x, or x squared, and then x times y, plus xy, and then minus y times x, minus xy if you like, and finally minus y times y, which is minus y squared. Now you can see the two terms in the middle cancel each other out, because they're a plus and a minus of the same thing, and we're left with x squared minus y squared. So in other words, x squared minus y squared equals x minus y, x plus y, giving us the difference of two squares rule. Let's have a look at it in practice. We're going to use that factorization to factorize these two expressions. Give yourself a moment now to try these out yourself, and then come back and join me to go through the solution. Okay. First of all, in A, you can see that we've got x squared minus 36. Now this one's fairly clear. We've got the square of x, and here 36 is easy to see as the square of 6. So if you really want to write it out, we could say x squared minus 6 squared. And then using the difference of two squares, formula or rule if you like, we can write that as x plus 6 times x minus 6, treating 6 like the y in the rule. And that should be perfectly fine as it is. If you like, you can of course expand the brackets out and check these things as usual. In part B, it's a little more obscure. We've got 75 minus 12a squared. Now I can't see 75 as being the square of anything, and similarly 12a squared as well doesn't look like the square of anything. But if we notice a common factor of 3, we're then left with 3 outside of 25 minus 4a squared, which can then be written as 3 outside of 5 squared minus 2a all squared. Now we've got a difference of squares, and we can use our rule to give us 3 by 5 plus 2a, 5 minus 2a. Again, you can expand it out to check. Two other special rules for factorizing are for the sum of two cubes and the difference of two cubes. When we have the sum of two cubed quantities, we can factor that as x plus y times x squared minus xy plus y squared. Note that this particular part is not factorizable any further with real numbers. Similarly, for the difference of two cubes, x cubed minus y cubed, we can factor as x minus y and x squared plus xy plus y squared. Again, this piece can't be factored any further with real numbers. So a couple of examples with these special rules. We're going to use the rules for the sums and difference of two cubes to factorize x cubed plus 27 and 16x minus 2x to the 4. Give yourself a couple of minutes now to try these out. Okay, first of all in A, obviously this one's going to be a sum of two cubes. We've got a plus in the middle there, and we can see that it's x cubed, and the other term here is 27, and 27 of course is 3 cubed. So we can start by writing x cubed plus 3 cubed. Then applying the special rule, we jump back, it's going to be x plus y, or in our case x plus 3, and then x squared minus 3x plus 9. So we have x plus 3, x squared, and it was minus the product of the two numbers, so minus 3x, and then plus 3 squared, or 9. Okay, in part B we've got 16x minus 2x to the 4, and this is one of those ones that doesn't look like cubes again. We can see it's a difference, but we don't really have cubes there. What I can see though is some common factors I can pull out from the start. So we can write that as, it looks like we've got a common factor of 2 and also of x. So 2x outside of, we'd be left with an 8. 8 times 2x is 16x, and take away x cubed. And of course that then we can write as 8 is 2 cubed minus x cubed, and we have a difference of 2 cubes in the parentheses. So we use our special rule for that, which is we're going to have x minus y, or in our case 2 minus x, and then the first term squared plus the product of the terms. 2 squared is 4, plus 2 times x, and plus the second term squared, which in our case is x, so plus x squared. And again, remember, this piece can't be factored any further with real numbers. Okay, so that's it for the examples with our special rules. So in this video, we've introduced some rules for factorising differences of squares and cubes, and also the sum of two cubed quantities. We've used those rules to factorise some example expressions.